We've briefly talked about actively validated services as an example of the middleware services. And next up, we'll dive into more details about AVS design principle. Let's have YQ joining us again, the founder of AltLayer, and Riad, a founder and CEO of Cubist. Jon, co-founder and CEO of Hyperlane. Louis, co-founder of Gelato. And Jiawei as the MC of the panel, investor of IOSG Ventures.
Hello, everyone. Here it comes to the AVS design principle panel. I'm super excited to have everyone working on AVS and the related technology here. So at the very beginning, I would like to give an opening remark. So as we all know, AltLayer has launched the first stage of mainnet and has already achieved over 9 billion TVL. AVS, known as the actively validating service, will benefit from the shared security provided by risk-takers. However, the public is still not very familiar with AVS, given that AVS has different types, different demands of economic security, and different risk frameworks. In this panel, we are fortunate to invite 4 experts who are building AVS to explore the design space of AVS and its principles. So I would like everyone to introduce yourself and the projects you're working on. Yes, starting from Yao Qi.
Yeah, as I just mentioned, YQ here. We are building this platform to help application to launch like rollups and also real-estate rollups.
I'm Jon. Started Hyperlane with my co-founders. Hyperlane is an open framework for interoperability, and I guess the short of it is that it lets anyone connect any blockchain.
Hey, I'm Louis. I'm the co-founder of Gelato Network, and Gelato has been developing and shipping to production all sorts of Web3 middleware services, smart contract automation, account abstraction, VRF, actually recently is popping off on Blast and Avalanche apparently. So yeah, and we also last year introduced our Rollup as a Service platform, where currently we have a bunch of customers that deploy Arbitrum Orbit chains, OP stack chains, Polygon CDK chains on Gelato. And yeah, we sort of help them do more than just a rollup. We go the extra mile here. We call ourselves a Web3 cloud platform, and that means that alongside with the rollup, we also provide you with access to our serverless environments so that you can, from day one, stream data from oracles on your rollup. Very useful for DeFi applications and yeah, all the other services that we have on the platform to actually not just deliver block space, but actually rich block space full of services and automation.
And hi, I'm Riad. I'm co-founder and CEO of Cubist. We work on key management infrastructure, which maybe seems like a weird fit with the rest of the panel here, but we think about it in a bunch of different ways. So of course we work with folks building wallets, building trading platforms, etc. But most relevant here, we work with folks who are building massive validator services. And in that regard, we've been thinking a lot about this notion of anti-slashing. So it's not just make sure that I hopefully don't get slashed. It's how do we come up with a criterion that lets us say, for certain, as long as we have this, as long as this criterion is fulfilled, you can be certain that you will never be slashed. So on Ethereum, there's an EIP that talks about this is how to avoid being slashed. We've taken that and turned it into essentially a hardware-backed piece of software that guarantees, because it knows the history of everything that a key has signed and it serializes every signature that the key ever makes, it can be certain when it releases a signature that that signature cannot possibly be slashable given the history of this key's signatures. So what we've been thinking about a lot recently is extending that kind of technology to things like Babylon, and notably here to things like AVS design.
Thank you, everyone. So to begin with, I think I've got a general question for all. Let's do some brainstorming. If we aim to create a live dashboard for AVS, let's say similar to L2Bs today, what key factors should we display? Like, for example, for L2s, we show analysis like DA, sequencer, and proofs and ZK stuff. For AVS, we can display information about the AVS and operator, the amount of delegated E's and slashing conditions, among other things. So what do you think will be the key factors that we should show to developers and users?
I think you mentioned developers and users. You haven't gotten into the person that really matters the most is who's paying for it? What do they want to know? And I think the thing they want to know most is, I'm going to pay you, say, $10 a year for this sense of security. Who else is paying $10 a year for this same amount? Because the moment that someone else starts paying for this same amount, it's worth a whole lot less to me as the person who first paid for it. So what I really want to know is, how often is this, dollar amount, this economic security, effectively, if you want to call it rehypothecated, replicated, whatever it is. I want to know who is placing the slashing claim on it, because I can go out there, I could be a good citizen, I could do everything right, and I've been paying all my premiums just as prescribed, and then one of these other people, they were not good citizens, they got the pool slashed, and now I'm out of luck. And do I get a refund? I don't think I get a refund. So knowing who else is paying for it, how many claims are there, what are their slashing conditions, is the most important thing, at least in my book. And I can tell you, as a group that has been involved in this and is thinking about different forms of economic security, and we talk to all the different capital providers, right? The LRT folks, that's top of mind for them.
An interesting point. I sometimes say that crypto startups don't get insurance, so AltLayer had to be invented. I'm sure you guys know that it's very hard to get insurance as a crypto startup or a startup in general, I guess, but crypto startup, good luck. And what you just described sounds almost like an insurance policy.
It's exactly that.
Yeah, right.
I think so I used to be a bond trader way back then, and I find that a lot of people think about this as some type of securitization market, but I actually think it's an insurance market. And the pool, the providers of that capital, need to think of themselves as insurance providers. They are not, they're not like asset appreciators, they are liability matchers. And right, in finance, those are two key distinctions. It's very much like an insurance pool. I'm glad you said it.
So I think from the perspective of somebody who's, kind of down in the weeds of the infrastructure, if I'm looking at a dashboard of AVSs, I want to know, we've already heard things like, I want to know their slashing condition. I want to see not just like this detailed thing that nobody is going to pay attention to. I want to see a yes, no. Is this an objective slashing condition or not? Because if it's not, you should immediately be afraid. You should immediately know that you're taking significantly more risk putting capital there. So that kind of thing, immediately giving people warning bells. Okay, next, I want to know, is the slashing condition, even if it's objective, sometimes it's in a slashing condition that's actually very hard to enforce or to anti-slash. So if you look at Ethereum, for example, you need only a sort of constant amount of data about the history of key's signatures to decide for certain whether that a signature is not slashable. You need a linear amount in the number of signatures if you want to have a precise notion of yes or no, but you can at least have a conservative notion of whether it's slashable or not with a constant amount of data. I want slashing conditions that look like that because I want to know that the software that's making sure that a slashable block is not signed is simple and is actually likely to be correct. And on that topic, and I promise I'll stop after this, I want to know about the maturity of the software that the AVS operators are running in order to participate in this AVS. Is it built on a library that has a long history? Was it developed in a language that I think gives it a good shot at avoiding obvious bugs? Is it shared in some way with other AVSs? What's the history of bugs in the AVS software? Because all of that is also a risk that has nothing to do with misbehavior and is likely, in my opinion, to be the major cause, at least in the near term, of actual problems with AVSs. We're writing brand new software for these things. We're going to have tons of bugs.
So typically, as Jiawei just mentioned, right? Because users in crypto, it means a lot. It's typical we call it retail investors, and they are also community members. Sometimes they also drive the DAO governance, and for these kind of users, right? Similar to L2Bit, the first thing we need to show is a TVL. Even the TVL is not a liquid position. Typically, it's like locked assets for the shared security from EigenLayer, right? But it's a very important matrix for no matter what kind of services we provide. And the second thing I would say, of course, is about utility. I believe a lot of the audience, and even when we talk to a lot of friends, they don't really understand what's AVS. I mean, of course, they understand it can be used to secure some product, right? But they don't understand what's the real product, like powered by these AVS or EigenLayer. So that's why I think the second thing, like compared to all the rollups or L2s, right? Typically, they are general purpose. So we can expect you deploy smart contract on these L2s. But for a lot of AVS, like Jon building the like bridge or interoperability layer, right? We don't expect to deploy smart contract on that. For example, some of our AVS, like we are providing the decentralized verification. You also don't expect like to deploy contract there, right? You just expect probably there's an API or something. You can send the query and get the result. So that's a very major difference compared to the typical L2 stats and dashboard. And then of course, as Riad and also Luis mentioned, the slashing condition, because that's also very important. Even probably at the beginning, there's no slashing mechanism, but still, people need to know, like, okay, if there's something wrong happen, right? Well, how much my stake is slashed from it? It can't be zero. If it's zero, there's no point to use this system. And then the next thing will be payment. Like, when can I withdraw my earnings, right? It can't be just say, okay, even it's a point system, what kind of points I can earn, because I can delegate to multiple AVS. Probably I can earn like 10 points here, like 5 points there. And then the last one I would say is really about like the AVS itself, like, because every AVS is different from each other. You must show like sort of the status, like the operator status, who are the operators supporting this AVS. So these things make AVS quite different from the traditional rollup or the L2, L1 system, because it's not general purpose. Mostly, most of them actually are application specific. Yeah.
Thank you. I've got some specific questions for each founders. So for starting from Luis, we know Gelato position as the Web3 cloud platform. Gelato provides many great tooling, including Rob as a service, automation, relay, VRF, and more. These services are all related to node operation. So the question is, could you share some experience based on these node operations that you guys are running for quite a while? And how do you think restaking can optimize this product line and move towards like further decentralization?
Yeah, there was node operation, right? Yeah. So first of all, restaking won't solve everything and also is not needed everywhere.
How dare you?
But there are certain interesting use cases for it. So on the rollup as a service front, I am actually a bit of a skeptic of decentralized sequencing. I know this is touted to be one of the main use cases, but for me, I don't see why, because I think the point of rollups was that you can have centralized sequencers and you have fraud-proof technology, ZK-proof technology to make that a world that is okay to live in. And you can benefit of the scalability properties of centralized systems while still retaining the properties of Ethereum, the asset layer, and ultimately Ethereum will save you if the rollup operator is somewhat like faulty or even fraudulent. So I think decentralized sequencing, and actually I think 3RAM agrees with me on this, at least as per my session with him this morning, is maybe not as much of a use case as people think, but I'm happy to be proven wrong there. So, I mean, as a rollup as a service provider, people would probably immediately think, okay, we're gonna use EigenLayer for sequencing, but I'm still a bit skeptical there. But it might actually be useful for fast confirmations on shared sequencing and so on. I think that's really interesting. Shared sequencing is really interesting in general, not just in the Ethereum-based rollup sense, but also like if you have a game, right, and you actually have one of these games, hopefully that will go live soon, where they have massive user bases similar to, I don't know, Web3 MMORPGs, and they're actually, if they want to have synchronous shards and so on, they need shared sequencing, and I think they're having a notion of fast confirmations or like even for DeFi apps with high throughput. I think that could be very interesting. In terms of other Gelato services, definitely, I mean, Oracles is a no-brainer. I think it's really, really bullish what EigenLayer is doing there with restaking. It's basically reducing the barrier to entry for Oracles. What I would like to see is actually have this be framed as more of an insurance policy that works for Oracles. Then I think this makes a lot of sense. As a Oracle startup, you probably would love to have insurance in case something goes wrong, because things can go wrong and will go wrong. So I think that's really great, and we're working with our serverless environment that is heavily used by Pyth and by Redstone users, for example. They usually work in conjunction with Gelato, and I think there it's very interesting. And also for bridging, I mean, bridging is sort of similar to Oracles, right? Like if you want to bootstrap a bridge, which is going to be insanely important if we want to launch 100, 1,000 rollups, right? Like a lot of these great bridging models like Across and so on, they simply don't scale to that yet. So there you will probably have to, deploy your own bridge of sorts with Hyperlane or similar, and there maybe, a restaking I think is also going to be interesting. Again, as an insurance policy, as an insurance fund, maybe the new Nexus Mutual, I don't know. But I'm not an insurance guy. I would love to talk to you afterwards too. Maybe you can explain me a bunch about that. But that's how I see it. There's certain use cases for it. But yeah, we'll have to see. Let's wait until it launches, and I'm sure people will use it.
Thank you, Luis. Very interesting point of views. And another question for both Yao Qi and Jon. So we know AltLayer and Hyperlane are working pretty closely with the EigenLayer team as the pilot AVS from the very beginning. Could you share some experiences or lessons learned from the journey of designing your own AVS?
I guess to go back to what I was saying earlier, I think the area that still remains as the biggest open question is, how do you pay for this? Right now, the way you pay for this is basically EigenPoints is paying for this. 9 billion in EigenLayer contracts right at this moment in time is paid for by EigenPoints. Once it transitions to AVSs, how do you pay for it? How do you price it? And that is the biggest open design question. And so we have several ideas of what we want to do with this. The thing that is kind of like the obvious one, and this one comes into contact with what Riad was saying earlier. Well, you can use it to secure messages or information that goes out of Ethereum. If the transactions that are being secured by that AVS happen on Ethereum, the slashing mechanism, you can engage in some form of permissionless slashing, because in that case, the crime happens on the chain where the stake lives, and so anyone can observe the crime because it is included in some block. Anyone can initiate the slashing command, and so we can have a pretty clean separation of judge, jury, and the police, who basically have to catch the criminal. What ultimately we want to do is not secure things on Ethereum, because that's not that useful, I would say, right? That you can do that today, and EigenLayer adds to that, but it's not revolutionizing in that context. What we really want to do is work closely with these guys and their ultimate clientele, right? Their roll-ups, and use economic security wherever it comes from. EigenLayer has produced a great pool that you can draw from, and then secure the outbound going from those rollups so that you don't have to wait 7 days. Right now, you can make a transfer between any of the L2s that Hyperlane is on to any other chain. And on the long end, that takes 30 seconds from the moment initiated until the moment it is included on a block somewhere else. That happens right now through like these validator committees. No economic security live yet. You really want to do that. But then think of what I was just saying earlier. You do this, and now you have this different problem. If the stake remains on Ethereum, but the crime happens somewhere else, how do you communicate about that crime? Well, it probably can't be through the same channel that is secured by the AVS, right? Because then what ends up happening is that the people who need to be punished are the only way to report the crime. And that is like a big, for us, it used to be a big open design question. Now there are several kind of lanes that we can explore and are exploring. But who matters? Who matters in this is the person putting the capital at risk, and they need to consign to it. Now, happy to report that most of the LRTs so far are actually comfortable with this, and they see this too as one of the end games for restaking. So there's been a lot of buy-in, but his point is the best point here tonight. How battle tested are these systems? Does this, so you have slashing, is it enforceable? Is it actionable? And then even with those two things, at which point does it get turned on? And so that's like, sorry for bloviating, but that's how we've been thinking about it and like how what we've been dealing with.
So on our side, I've been close friend with Ram like a long year ago, even before this restaking effort. On our side, we are working closely with them on like all different fronts. The first thing is on the EigenDA. We are basically helping Eigen team to do a lot of the integrations with OP-Stack, Arbitrum Orbit, and also upcoming the Polygon CDK. So the thing is like we also provide a lot of advice and suggestions on the design of the EigenDA itself. So right now, if you use EigenDA, you can see that it's very developer friendly compared to the other DA solutions, because like somehow we figure out like a bunch of these solutions to make it like the developer as the first citizen. The other thing is about this AVS design, because we are building these rollups for a lot of partners in different sectors. And at the same time, we are heavily involved in a lot of these designs in different components. So for the AVS itself, probably at the beginning, you will see the first version may not have some of the features, but it would be great like we can have the first version. After that, we can evolve to have some new features like this payment and slashing mechanism. I totally agree with Jon on this slashing mechanism, because the beauty of EigenLayer compared to all the other different systems is on the slashing part. For any shared security system, if you don't have slashing, that means you couldn't really leverage the security. So basically, even you have like 9 billion ETH, but if you don't have a proper mechanism to leverage the condition, then sort of like this, like even this high TVL is not used properly for your system. And beyond that, for the we also work closely with the other different teams like LRT teams and also operators. We feel like at least at my point, from my perspective, that because previously we did a lot of research on this dark forest and MEV stuff. Now I feel that probably for the first version of EigenLayer, the entire ecosystem will become into this new dark forest. We can see that there will be a lot of challenges and also opportunities. Not just for AVS here, and later we also organize another event, but also for operators and basically the LRT, LITs, LSTs, because no one knows for this new system, right? What's the best strategy to either become a LST, LRT, or operator or AVS? Even as AVS, we want to provide the best sort of yield or whatever, but how to make it possible in this complex system to make sure like user can get the yield, but at the same time take little risk. So there's a lot of calculation and balance we need to make, not just from the project perspective, but in general, as John mentioned, it's a lot of open research questions. So that's why when I talk to a lot of my friends and also Eigen team, I told them I'm so excited now I can publish another 10 research papers for just this risk-taking ecosystem, because it definitely opened sort of a new world for all the developers in blockchain space to explore.
Thank you, John and Louis. Thank you, John and Yao Qi. So for Riad, we know Cubist team has very strong academic and industrial experience in the security space. So based on your practice, what are the security aspects that AVS developers should keep in mind and pay attention to?
Well, so I mean, I've kind of given away the game already with my prior answer, but I want to emphasize again, like, at first, with your AVS designs, please be conservative. We're still learning how the dynamics of this entire system will work, and you're not building in a vacuum. So as you build, the things that you build will interact with other things in ways that you don't necessarily expect, and we haven't learned yet what guardrails we should put in place to make sure that these systems behave the way that we think they should. So to me, it's be conservative with your AVS designs, and it's, to the best extent possible, build on trusted existing software when you're actually building the software that's going to run your AVSs. But I think the other thing that, and this comes back to the very first thing that we talked about, think about the mechanisms that you're using to communicate to the wider world why your AVS should be trustworthy, right? We're kind of in this, new dark forest where there's kind of one version of it that's not going to go away, which is sort of everything that happens on chain. But I think the kind of thing that we hope will go away is the veil of ignorance that we're all under right now as to how the system as a whole works. We don't have yet an information ecosystem that tells people these are the operators that will be that are trustworthy. These are the AVSs whose yield is reasonable given the risk that you're taking. These are the types of designs that are probably going to behave the way we expect. So I think to the greatest extent possible, we should all be pushing to build this information superstructure as quickly as possible. And so as you're designing your AVSs, I think one important thing is, how can you communicate that to the outside world? Whether that's, very obvious things like, of course, have your software audited, but also things like you should be thinking about how your operators ought to be interacting with your AVS. Like, what do you expect from them in terms of operations? What do you expect from them in terms of, transparency about those operations? So I think these are the sorts of things that we can all do to kind of converge more quickly to a stable ecosystem and to avoid some of the probably mostly unavoidable bumps along the way.
All right. Thank you, everyone. And we just had a best collaboration on time. And thank you. And thank you for all your incredible views. Yeah, that's all for this panel.
Thank you.
Thank you, guys.
That's awesome.